Like this video if you find it useful and subscribe to this channel for additional content. In this lesson, we will talk about the product rule of differentiation. The product rule comes in mind when two functions are being multiplied, okay? So the first function is x squared being multiplied by another function, x minus 1 or raised to the power 3. Now, if you are asked to differentiate this function, one might want to expand. So after you expand, then you differentiate. But there's a better way to do this, and that is what we call the product rule. So these two functions, we would denote them by different variables, okay? So let u be equal to the first function, which is x squared, all right? Then v should be equal to the second function, and that is x minus 1 raised to the power 3, all right? So for us to differentiate, we have a formula that we use, and that is called the product rule formula, okay? So product rule formula, okay? All right, so does it come with R or not? I mean, who cares? It's English. So dy dx is given as, you hold the first constant and then you differentiate the second one, okay? Plus you hold the second one constant and then you differentiate the first one, all right? So solving this, okay, this y is equal to x squared x minus 1 raised to the power 3 would imply that we said let u be equal to the first one and the second one be what? Be v, right? So it means your y is now uv, okay? All right, so we are told to keep the first one but differentiate the v, right? So let's go and look for dv dx. We said v is equal to this, so we have v equals x minus 1 raised to the power 3. So dv dx, this would employ chain rule. So differentiate the outer, which will give you 3x minus 1, okay, x minus 1. Then you subtract 1 from the power, making 2, okay? Then you differentiate the inner. If you differentiate x, gives you 1, all right? So this gives 3x minus 1 all squared. Then what else do we need? We need du dx, okay? We know that u gave us x squared. So du dx will give us 2x, all right? Now, the formula says u, so dy dx, u, so where is u? This is u, right? So that is x squared times what? dv dx. dv dx, we got this. So that is times 3 into brackets x minus 1 squared, all right? Plus what? V, what is v? V is here. X minus 1 raised to the power 3 times what? du dx. What is du dx? That is 2x, so 2x. Then we clean up, okay? So we get 3x squared into x minus 1 all squared plus 2x into x minus 1 cube, okay? So this would be fine, all right? But if you want to further solve this, it's allowed. Why not? You have x minus 1, okay? So you can factor x minus 1 raised to the power 2, okay? Since this has power 3, so that's a common factor of x minus 1 raised to the power 2. Also, you have x here and you have s squared, so you can factor out x. So you have x out, x minus 1, okay, raised to the power 2 out, and then you are left with 3x, all right? Then plus, you are left with 2 here, and then x minus 1, okay? So you clean up further, all right? So this 3x, you have plus 2x minus 2, all right? So that would give you x minus 1 all squared. Then you have 5x minus 2, all right? So you can end here. So let's solve another example under product rule and see how to apply the same trick. So this one, we have a very simple question, 2x, and then we have 3x plus 5, okay? It's called product rule because you are multiplying two functions, okay? This and that. So let u be equal to the first function, which is 2x, okay? The trick is that you already know your formula for the product rule is u dv dx plus v du dx, okay? So as soon as you write u as this and then v as the second function, you should go on and differentiate right away so that you have du dx, which is 2, and then dv dx, which gives you 3, okay? Therefore, dy dx, all right, u first, what is u? Is 2x. Multiply by what? Dv dx. Dv dx was 3. Plus v, this is your v, 3x plus 5, okay? Times what? Du dx. What is du dx? That is 2, okay? Then you clean up. So you have 6x plus 2 into 3x plus 5, okay? So you have 6x plus 6x plus 10. So you have 12x plus 10, okay? Now, you don't always need this formula, all right? The meaning of this formula is that if you have y is equal to two functions, u and v, okay? What this formula is saying is that maintain the first function, okay, and differentiate the second function, plus now maintain the second function and differentiate the first function, okay? So we are going to solve another example. We shall call it example 3. And this time round, we will not use any formula. We would just use the meaning and then work with it. So y is equal to x into x plus 4. The instruction is differentiate this function, okay? This function. All right. So, like I said, dy dx is equal to maintain the first function, so we will maintain it. Then we will differentiate the second function. When you differentiate the second function, you get 1 plus, now maintain the second function and then differentiate the first function. And when you differentiate x, you have 1, okay? Then you clean it up. So you have x plus 4. And that is your answer. So that is the idea. Maintain the first function, differentiate the second one, or maintain the second one, and then differentiate the first function.